Okay, so in this video, we're going to use star, but rather than adding it as a parameter to a function definition, we're going to see how we can use it as an argument when we actually execute a function. So it will make more sense with an example as always, but what it allows us to do when we pass star as an argument to a function, it will unpack values. What does unpack mean in this case? Let's take a look at some code. So here I have this function that we've been working with, sum all values. Takes in star args as a parameter. Again, we could call it nums instead. All it does is it has a total variable, loops through everything in args. So we could have one number or 50 numbers being passed in, and it adds them to a total. And then it prints total rather than returning it, even though printing is not anywhere near as useful as returning. It's just easier for now, so I don't have to type print all the time. So right now to execute this, we would do something like 1, 30, 2, 5, 6, right? And if we execute it, we go Python 3, I call this file unpacking.py, we get the sum. So that's great. But what if I had a list of numbers? In this case, let's say this list right here, 1, 2, 3, 4, 5, 6, and I'll just call this nums. What if I wanted to call sum all values and I wanted nums to be passed in? So I want these numbers. And this is actually common when, we might, consecutive numbers like this, definitely not common, but you have a list of things and you want to unpack them, split them apart, and send it to a function that is expecting individual arguments. This function is not written expecting a list. And in fact, let's just take a look at what happens if I pass in nums directly. What do you think will happen? We get an error, and it says unsupported operand type for plus equals int and list. So to unpack what's happening here, let's just print out the value of args at the very beginning before we even hit any errors, and let's rerun it. Here is what args looks like. It's a tuple, because remember, it's always a tuple. It collects everything that's been passed in as an argument and puts them in a tuple, but in this case, only one item was passed in, so it's a one item long tuple. Remember in the last video, we saw that Python will add a comma, a trailing comma, if it's a one item long tuple, just to distinguish it from regular parens. So this doesn't work for us because what happens is total is still 0, that's fine. For num in args, well, there's one thing in args. So one time through, num is going to be equal to a list. So we're going to try to take total, which is 0, an integer, and plus equals an entire list, which is not going to work. Okay, so you might think, what if instead of a list, nums was a tuple? Could we pass that in directly, sum all values with a tuple? What happens now? We get the same problem, except rather than an int and list discrepancy, it's an int and tuple, because this is what args looks like. It's a tuple with one item in it, which just happens to be another tuple. Same problem as before. So what we actually need is a way to say, okay, take everything in this tuple or take everything in this list and turn them into individual arguments that we pass into this function. And it's nice and easy. This is where the star comes in. It just looks like this, star nums. And it works both with tuples and lists, but I'll show you now. If we run this, this is what args looks like, and the result we get printed out is 21. So by adding that star right there, it basically says take this collection, this list, or in this case, this tuple, and go through it and pass each one of these in, each element or each item, as a separate argument. So then star args collects all of these inside of one tuple. So 1 was sent, 2 was sent, 3, and so on. Same thing if we had a list instead. We'll get the exact same value, but just to show you. There we go. We get 21 again. So it also passes them in individually. So this is called unpacking. Hopefully you can see why it's called unpacking. We are taking a collection and chopping it up, unpacking it into individual components and passing them each through. So very useful. A lot of times we're working with lists or tuples and we need to split them up to pass them into functions.